All right, guys, so before we get into the rational zero test that I'm going to be explaining later, the first thing I want to review real quick is how we do synthetic division. So just as a review, remember if I'm dividing these two things, what I'm going to do is I'm going to make my little L thing, and I need to make sure on the outside I put whatever makes x plus 7 equal to 0. So if you imagine -7 plus 7 equals 0. Now, on the inside of my L, what I'm going to do is I'm going to put the coefficients. And I need to make sure, see how I jump from x to the fourth to x squared? I need to make sure I put a 0 placeholder in there. So 0, -4, that's a 4. And then I also skip over x, so I need a 0 there, and then 3 on the end. All right, so the first thing I do is I bring down the 1. -7 times 1 is -7. Add down, I get -7. -7 times -7 is 49. Okay, and then let's see, -4 plus 49 is 45. And -7 times 45 is definitely -315. Okay, and then we get -315 times -7, which is -2, or actually positive 2,205. And so then I add down again and get 2,208. Now, this is just a random example that ended up not working out well, but overall, we need to remember that this means that once they're divided, I get x cubed minus 7x squared plus 45x minus 315 plus 2208 over x plus 7. Okay, so for this video, this is going to be our learning target for today. So make sure that by the end of this video that you at least know or can at least begin to do this learning target. So you should be able to use the rational zero test to find the zeros of any polynomial that I give you. So if we look at the rational zero test, it's very long, very difficult to read. This is the one that shows up in textbooks that you probably do not understand hardly at all. But this is the important part, right down here. Okay, so what we need to know is that P is the factor of a sub 0, which is the constant term of our polynomial. Okay, Q is the factors of the leading coefficient. Okay, and so all the rational zeros that we can find are in the list of plus or minus P divided by Q candidates. So what does that actually mean? Okay, so our possible rational zeros are going to come from this list of numbers. Factors of the constant term over the factors of the leading coefficient. So, for example, I'm just going to list out the possible coefficients. So, first of all, you have to start with a plus or minus and a division sign. So I'm going to take the factors of the constant term. So what are the factors of 1? Well, let's remember what factors are. Factors are the things that multiply to that thing. So for example, the factors of 1 are obviously just 1. Okay, and the factors of my leading coefficient that go on the bottom, technically there's an imaginary 1 there. So my only possible rational zeros of this polynomial are plus or minus 1. Okay, so those are the ones that I would be testing through synthetic division here in a little bit. Okay, so let's see what it actually looks like to find our rational zeros. So what we're going to do is we're going to first make our list. So if you imagine, I take the factors of my constant term, 1, 2, 3, and 6. Okay, so 1 times 6 is 6, 2 times 3 is 6, nothing else multiplies to 6, over the factors of my leading coefficient, which is 1. And so here's my options. Plus or minus 1 over 1, which is 1. Plus or minus 2 over 1, which is 2. Plus or minus 3 over 1, which is 3. And plus or minus 6 over 1, which is 6. So those are the only ones that I am going to test using synthetic division. So if you imagine, if I test this out, okay, I'm going to put 1, -1, 1, -3, -6. Now, if something is a 0, I should get no remainder when I am left dividing. So what I'm going to do, I'm going to think about, okay, well, I need this to be 6. And when it comes down to it, if I don't get 6 there, then I know that that 0 doesn't work and it'll never work. Okay, so I'm going to bring down the 1. Okay, and so let's just test. Let's test 1. 1 times 1 is 1. I get 0. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. And then I'm going to get -2, and I don't get 6. So all I do is I'm going to erase, and I'm going to try something else. Okay, so let's see. Let's try 2. If I bring the 1 down, 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. And let's see, 1 plus 2 is 3. 2 times 3 is 6. 3. And that one does work. 2 times 3 is 6. So this is what I'm left with. Okay, so once I get one that works, that doesn't necessarily mean that that one will never work again. So it doesn't take it out of my list. But I do know that now I can move down and I can just use the numbers that I was left with to keep going. Okay, so for example, let's try 2 again. So 2 times 1 is 2. 1 plus 2 is 3. 6. This is going to be 9, and that's not going to get me. Remember that this needs to be -3 so that I get 0. Okay, so if I go erase, I'm going to erase this, erase this. Okay, so now 2 is eliminated. Remember that we already eliminated +1. Let's see. Let's try -2. Okay, so 1, -2, -1, and +2, 5. Yeah, that's not going to work either. So let's erase that. And yes, if you're wondering, this is a lot of just guessing and checking. But eventually, once we get down close enough, you'll get a better idea of which ones will actually work. Okay, so -2 didn't work. +2 doesn't work anymore. Let's try -1. So we get 1, -1, 0, and then 0, 3. Hey, that one works. Okay, so now I have 2 zeros. Okay, so I know that x equals 2 and x equals -1 are 2 of my zeros. Now, once I get down close enough, what I need to start thinking about is, what does this polynomial look like now? Okay, so if you imagine, now this is my remainder, this is my constant, this is x, and this is x squared. Okay, so this polynomial looks like x squared plus 3. So if you imagine this one, what I can do now is I can just set that equal to 0 and solve for x pretty easily. So I don't need to just keep going if I already know how to solve this. So for example, x squared is going to be equal to -3. And if I take the square root, remember that when I square root negatives, I get some form of imaginary number. So I'm going to get plus or minus I square roots of 3. So if you notice, this was a 4th degree polynomial, so I have 1, 2, 3, and 4 x-intercepts, roots, or zeros. Okay, and so that's how we're going to do all of these. So remember, again, that all I'm going to do is I'm going to take the factors of the constant over the factors of the leading coefficient, try them out until I get down to something that I can either factor or solve or do something like that. So let's try one where the leading coefficient isn't 1, so we can see how this is going to work with different kinds of fractions. Okay, so if I find the possible rational zeros, I take plus or minus the factors of the constant, which are 1 and 3, and the factors of the leading coefficient, which are 1 and 2, and this becomes my list. So I do 1 over 1. Okay, so I'm going to take, for example, 1 right there over 1, and that gives me plus or minus 1. 3 over 1 is 3. And then what I also have to do is I have to take this 1 over 2 and 3 over 2. So I do have fractions in this. So, for example, I have plus or minus 1/2 and plus or minus 3/2. Okay, so what we're going to do, we're going to test these out again. So I have 2, 3, -8, and 3. All right, so the one that I always test first, remember that I need -3 there, and 2 is going to be brought down right there. The one I test first is going to be 1. So 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. -3. Hey, right off the bat, 1 works. Okay, because I get 0. So now, again, what I can do is I can just use these coefficients now. Okay, and so I'm going to kind of erase that because now I'm just down to 2, 5, and -3. And I can continue going through my list, or if you can recognize that this polynomial, okay, so this 2, 5, and -3, if you are a person that likes to factor, which I know hardly any of you are, but in case you like that better than this, notice that this is 2x squared plus 5x minus 3. Okay, what you can do is you can factor this and get your zeros that way. Okay, so we practice all that factoring, AC method or box and diamond, whatever you want to do. You can factor and find your other zeros. You don't have to continue to do this synthetic division until you get to the end. You can get to whatever point you want to and find your other zeros. So for example, if I did that, you would factor this, and let's see, 2x times x is 2x squared, and then I would get plus 3 over here, minus 1 over here. And so then when I went to find my zeros, this would be x equals -3 and x equals positive 1/2. And notice that those two things are also in our list up here. Okay, so that's another way to check that you got the right zeros. So now I'll show you that these in fact still work. So for example, if I would have chose -3, 2, this would have been -6, and this would have been -1. -3 times -1 is 3, and then I get 0. And then finally, for the last one, if I do 1/2, if I bring the 2 down, 1/2 of 2 is 1, and I get 0 again. Okay, so these 3 are my zeros for my polynomial. Okay, so the overall purpose of the rational zero test is we want to know all of the zeros of a polynomial so that we can graph them accurately. So we're going to use the rational zero test to find all the rational ones, and then use what we know about factoring solving to find the other zeros. Okay, so ultimately remember that the goal of this entire unit is that we're going to be able to graph them and graph them accurately. So know that where all your x-intercepts are, know your end behavior so that you can graph things accurately. Okay, so now you can move on to the rational zero practice. So you can practice finding all the rational zeros and all the other zeros for your polynomials. Again, if you need any help with that, just call me over and I will help you.